Hi, welcome back. Last time we were talking about how when we change the value of beta, how does that impact the fraction of the population that got infected, as if we keep gamma fixed. So we can see here that by defining gamma to be 0.2, this is what we did before. I'm wondering why it's telling me that gamma is equal to 0.7. Let's rerun this and see if that fixes it. That gamma, when gamma is equal to 0.2, this is the different values of, for different values of beta, we get different fractions of the population that got sick. So that's saying that if you have 20%, if beta is 0.2 and gamma is 0.2, 10% of the population gets sick. Whereas once you get beta is over 0.6, so remember what beta represents. It represents the likelihood that the disease passes between a susceptible person and an infected person. Then we're getting to a really high percentage of the population that gets sick. So a natural question here is, what happens if we have different values of gamma at the same time? So we vary beta and gamma at the same time. And so that's what's happening in the next section of these notes, where what we were doing right now is we were running our code where we were sweeping beta with a fixed gamma. And now what we'll do is we'll create a plot for different values of gamma at the same time. So really we're sweeping both beta and gamma at the same time. All right, so we'll create different values for what gamma can be. Here gamma goes between 0 and 0.1 and 0.7. And now we're running a for loop, where in this for loop we're choosing different values of gamma in this array. So gamma is 0.1, then gamma is 0.3, gamma is 0.5, gamma is 0.7. And for different values of gamma we can do this sweep. We are running the same sweep function, it's just that the gamma is changing. And so when we do that, and we plot each of them, so in this for loop we're creating a plot for each of the values. Python puts all the plots on the same graph. And when you do that, you get this, I think it's a pretty interesting graph. It's taking a while because it's running the simulation many, many times. Let's see, we get this chart. All right, so let's investigate what's happening. It's saying that when gamma is low, remember what's gamma representing? Gamma is representing how long it takes to get better. And what low values of gamma mean that it takes a really long time to get better. And high values of gamma means that it takes a not very long amount of time to get better. Whereas beta represents how likely it is to transmit the disease. So this blue curve represents the fact that it takes a very long time to get better. And so if it takes a very long time to get better, then if it's very likely that you pass the disease on to somebody else, if you have a susceptible person and an infected person that get together, then it's very likely that the whole population will get sick. On the other hand, if gamma is very low, so people get better very quickly, then people move from I into R rather quickly. That means there's not very many people who are infected at one time. And so if it's unlikely that people interact with each other and pass the disease on, then a very small percentage of the population is going to get sick. All right, so that's what's happening in this section, and that's where we're going to leave it. All right, take care.